Hello and welcome. Today we are taking a gentle first step into a beautiful and essential concept. We are going to explore the very foundation of mathematics, sets. Let's begin our introduction to sets together. You might be wondering, what exactly is a set? In mathematical terms, the formal definition of a set is quite simple. It is a well-defined, unordered collection of distinct objects. We call the objects inside a set its elements or members. And the wonderful thing is, these members can be anything at all. They can be numbers, they can be letters, or they can even be other sets. Let's break that definition down into 3 simple rules, starting with Rule 1. A set must be well-defined. What does well-defined mean? It means there is absolutely zero ambiguity. Anyone looking at an object must be able to say with 100% certainty whether it belongs in the set or not. For example, a valid set would be the set of all vowels in the English alphabet. Is the letter A in it? Yes. Is the letter Z in it? No. It is perfectly clear. On the other hand, an invalid set would be the set of the best cricket players in the world. Because deciding who is the best relies on personal opinion, it is not well defined. Moving on to Rule 2, the elements in a set must be distinct. What does distinct mean? It simply means we do not count repeats. Every single element in a set must be completely unique. Let's look at an example. Imagine we want to write the set of letters in the word apple. We would write our set as S equals A, P, L, E. Notice how even though the word apple has 2 P's, we only wrote the letter P once in our set. Our final rule, Rule 3, tells us that a set is an unordered collection. This means the sequence or the arrangement of the elements inside the curly braces is completely irrelevant. Think of a set like a simple bag. As long as the bag contains the exact same items, it is the exact same set. So set A, which contains A equals 1, 2, 3, is exactly the same as set B, which contains B equals 3, 1, 2. Shaking the bag might change the order of the numbers, but it doesn't change what's inside. Finally, how do we write all of this down in mathematical language? First, we always name our sets with capital letters like A, B, X, or Y. Then, we list the elements safely inside curly braces. If an element is inside our set, we say it belongs to the set. For example, if A equals 1, 2, 3, we write that the number 2 belongs to A like this, 2 in A. If an element is not in our set, we say it does not belong to. So we would write that 5 does not belong to A like this, 5 does not belong to A. And with that, you now know the fundamental language of sets.